Right then, the following quantities are vectors and scalars. Distance is a scalar and displacement is a vector. Momentum has got velocity, so it's momentum times velocity, it's a vector. Speed is a scalar and pressure is a scalar. Explain why adding two particular scalar quantities always produces the same results. Well, scalars are magnitudes, so you just add them together. But vectors, well, if you put one vector like this and then stick another vector on this, you're going to get, your resultant is going to be enormous. But if you then have vectors going in opposite directions, so you go this way and then the vector goes in the opposite direction, your resultant is going to be much, much smaller. So it's very much dependent on the direction of the vectors. You can see that if you made them go this way, for example, your resultant is going to be smaller than the top one as well, shown by the dashed line. So the answer there is to do with, but vectors have direction, and if the direction is adds together, it'll be bigger than if they're taken away from each other. So you'll get, it depends on the direction of the vector, essentially. Right, you've got a 30 Newton and a 40 Newton. So you've got 30 Newtons this way, and then you add on top of it a 40 Newtons, slightly longer. Your total resultant would be 70. So that's valid. You'd never get 80 because 30 plus, this is the maximum resultant you're going to get. So that's definitely wrong. And the smallest value you're going to get is if it goes like this and then using the tip to tail rule, it goes back. Well, you can never get 0 as well. So that's wrong. You can get 10 because look at that, 30 this way and then 40 this way will lead to a resultant of 10. So you can get that. And of course you can make the vectors any sorts of angle really. So if you go like this and like that, for example, you may end up with 30 this way and 40 this way, and then what you would have created, of course, would, if you do this absolutely right, you'd end up with a an isosceles triangle. Is that what it is? Yeah, an isosceles triangle. So you go 30, 30, and you're if you go 30 this way, and then you went 40 this way, then you could theoretically end up with a resultant in this direction, shown by the double arrows or triple arrows, of 30. So that is possible as well. So they're the ones that are possible. Which of the following statements concerning displacement is correct? Well, time is a scalar, so you're only looking at this one here. Time is a scalar is correct. Time is definitely not a vector quantity, that's incorrect. Speed is not a vector quantity, speed is a scalar. Speed is a scalar as well. Displacement, well, displacement is a vector. And since this is a vector here, and that's a scalar and a scalar, well, the quantity there is going to be a scalar. So, so the only one that is correct about displacement is given by velocity because it's in a direction. Displacement is distance in a direction. And so you could theoretically have something with a speed going around in circles and have 0 displacement. So it's important that you say which direction the velocity is in. So it's A. Let's explain that again. If things go around in a circle like this, the speed may be, I don't know, say, let's imagine you're doing 400 meters, say, in 40 seconds. Your speed would be 10 meters per second. But that would be your speed, okay? But your velocity, you haven't actually gone anywhere. You started there, you ended there. Your displacement therefore is 0. So it'd be 0 divided by 40, which is 0. So you can see what's going on there. A woman drove to her brother's house 60 kilometers due south on her own. So she goes due south on her own, and that takes her 1 hour. Okay, and then the next day she drives up to the north, and it takes her an hour as well. So she's travelled altogether 120 kilometers in 2 hours. So her speed would be 60 kilometers per hour, but her velocity would be 0 because she started and ended up in the same place. So her displacement is 0. So average speed, well, that's wrong because it's 60, so that's wrong. Her average velocity was 60. Well, no, it isn't. Her average, the velocity is 0 because it started here and ended here. So the displacement is 0, so that's wrong as well. Her average speed, no, we know it's 60, so that's wrong. Her average velocity is 0, so that's the right answer. The answer is D. A student, Alice, argues that the temperature of a vector, temperature is a vector because it can go up and down. Another student, Bikram, disagrees. Who is right and why? Well, Bikram is right. He's right because okay, temperature rises and falls, but that is just a change in magnitude. It's not a direction. So temperature doesn't really have a direction. It's got a change in magnitude. Yeah, things can get bigger in the same way that mass can get bigger and smaller. Length can get bigger and smaller, but they're not. Length is not a vector, and mass is not a vector. Joules, the energy can go up and down, but it's not a vector. So temperature is a scalar. So that's the answer. Bikram is right. And that's the end of that video there.